Alright, so we're going to go through here and we are going to program this part using a little macro program that I have for a setup. So the first thing I would do here is go and take my setup file and copy it. So inside of here I just got a generic setup program, so I'm just going to copy this here. I'm just going to paste this in the desktop. And we're going to change the name to something. We'll just go the old 1, 2, 3, 4. Alright, so there's my file right now that I'm going to use. There's already a standard outline in it for making a part. So I'm going to go in, I'm going to open this up, and we're going to do one of these. Come on. Did it wrong. Over here. There we go. And back to that. Okay, so here's our setup program and our part. So what I'm going to go do right now is just change the number off the top, and I'll get fancy here and I'll call it 1, 2, 3, 4. And here we'll just do I don't know, we'll call it 209 program lecture. Alright, so on the top of here, this is all kind of laid out in my setup program. This is a generic setup program that'll work for turning a lot of parts. I'm going to do everything in this part. I'm not going to worry about the drilling and tapping here, but I'm going to make all the outside shapes of this so that it's all programmed into this, and it would go and make this part. And if time permits here, I'm going to go out and just run it too so you can see it all function. So I'm going here. It's got all the setup information in here. Okay, here's our first macro variable. It says it wants a part length. Well, the overall part length in this part is 1 inch. Plus 500 thousandths, so it's 1 inch 500 thousandths. So I just go here and change this to 1.5. The stock diameter, okay, it's 1 1/4" 12L14. So the stock diameter I'm going to go and call 1.25. Then these variables here do some simple math here where it's going to take pound 102 is equal to pound 101 plus 50. So pound 101 is 1 inch 250. So it's basically going to say pound 102 is equal to 1.3. And then pound 103 here is pound 100 plus 123. So pound 100 or 103 is going to equal to 1.623. Anytime it refers to that in the program, it's going to be worth 1.623. Then it goes through, and again, 5222 automatically sets the G54 work offset, so it's doing all that for me. So far I entered 2 numbers. The bar pull, standard program, really nothing at all needs to change in this. It's going to pull it out, and since this is automatically setting the work offset, I don't really need to worry about it moving to a certain location. It's automatically going to do it as long as we touch off the tool in the machine. If the part length is 1.5 inches, it's going to pull it out 1.5 inches. If the part length was 25 inches, it's going to pull it out 25 inches because it's just going to go to that location of Z of 30 thousandths positive, and then since the part length is setting here the work offset, it's automatically going to pull all this out. So no edits at all in that block. Alright, in here, if you're familiar with lathe programming here, you would normally go over and you'd call out your RPMs and your surface footage, and then you would wrap it to a stock plus 50 thousandths. Well, I don't need to type anything in there because pound 102 is equal to pound 101 plus 50, so it's going to wrap it to x of 1.3. So when it reads this, it's just like it read x of 1.300. And z is going to go to 10 thou. It faces off. It comes back to that number. And so far, I haven't changed anything in there. If I wanted to, depending on my material, I might change my surface footage, so like 12L14, that stuff's butter, so I could turn this up to, I don't know, 800. So I can rough through there. My can cycle is all laid out here. There's really nothing to change on that. That'll work just fine. Then I come to my N1 here, and this is my part outline. So I need to do my first chamfer. Well, I'm not going to use cutter compensation, so I'm just going to have to add 10 thousandths to this chamfer size that I want. So what I'm going to do is in here, I'm going to change this. So if this is 70 thousandths, I'm going to bring it down 140 because I need to move double on X what I'm moving in Z to create a good chamfer. So I'm going to take my next number, which is right here, of X, and that's going to be the top of my major diameter. Well, my major diameter here is, looking closely, 748, 739. We're going to call that 0.745. So we're going to take 745 now, and we're going to subtract 140 off of that. And this number is going to become 605. So we change a couple numbers there. The z distance here is based on the chamfer size, so we're going to move back 70 thousandths, and that's because this was called at 60 and we're not using cutter comp, so we have to overcompensate a little bit. Then coming inside of here, there is no radius in there called out, so that's nice. Less work for me. But what there is a radius that comes up here. So I'm going to do this, and I'm just going to go and enter one space. So I'm going to turn it back to this distance. So this distance from the absolute z0, which is right here, is exactly 1 inch in length. So I'm just going to take this and go z minus 1. And then I'm going to add an x value here because I need to come up to the bottom of this radius. So I'm going to go up to x, and I need to figure this one out. And this is based on the diameter of the head, which it's 1 inch. So I'm going to take 1 minus, I want a 30 thousandths radius, and since it's a radius and it's outside, I have to add the radius on. So I need to write the radius for 45 again because I'm not using cutter comp, so I need to add 15 thousandths onto 30. So it's going to be 45, but then I need to double it to move it down, so it's going to come down 90. So that means this x value here is going to be 910. And then from there, instead of it being a G2, G2 is a clockwise radius, it's going to be a G03, so I'm just going to change this to G03, and I'm just going to put in X 1.0, and W, I can tell it to move over exactly 45, and radius, I'm going to tell it to move over 45, and feed. And then I'm at this point right here, I'm done with that. Honestly, the rest of this I do not need right here. Delete all that off. And it's going to go G1 Z minus 103. 103 is the, if you remember back in our code, 103 is 100 plus 123, so it's going to turn the part length plus the cutoff tool. So no need to put any data in there. Then it's going to end 2, and it's going to end at x upon 102, which is my stock diameter plus 50. No need to change any numbers there, so I'm done. The finisher is all set. Everything is macroed. It uses P1 and Q2. Nothing to do there. If I wanted to, I could turn the surface footage up, and that's about it. And that's done. The threading tool is just going to require me to fill in some thread data here. And I know this by heart. But this x value here is going to be my minor diameter of my thread, so that is 674. And the z length here is going to be whatever I'm threading to, and then I back it off about 5 thousandths, so I'm going to go 995. And the p value here I will fill in. This is my thread height, so it is the difference between the major and the minor of the thread divided by 2. So I'm just going to take 0.995 minus 0.745 minus 0.674, which is 71 thou, divide that by 2. This is going to become 35 thou and 5/10. And again, no decimal in this. This is a FANUC thing. It requires that. Q of 10 will be fine. Feed rate, I'm going to put in 1 divided by 16. That's going to be 0.625. And that's how I create the feed rate for the thread. Everything else is done, nothing else to do there. Then I'm going to my cutoff tool. It goes over, does everything, it plunges. So with this here, my cutoff tool has a 10 thou radius, so I'm going to add 10 thou onto this. So it's calling out 30. I'm going to write it for 40, which means I have to drop x by 80. So I take 1 inch minus 80 thou, it's going to plunge to 920. So it's going to plunge first, then it's going to come up and over, down, it's going to radius, and then it's going to cut it off. So I go down to 920 to start with, and then it pops back up to stock diameter plus 50. Nothing to add there. Here I need to move over the distance, which I said I'm making radius for 30 or 40, so I need to move this over 40. And then this is going to come down to 1 inch even. That's feeding fast. Then in this, instead of being a chamfer, it's going to be a radius. So I'm going to go G02, G03. Yes, so G03. So go to that, the diameter it's going to plunge to is going to be the same number I already figured out, the 920 from up here. And it's going to do its move there, and I just have to add an R into this of 0.040. Feeding slower, then it feeds right here. I'm just going to add a G1. After a radius move, you need to put a G1 in afterwards. It goes down to 180 thousandths, feeding faster, then it feeds a little slower. Parts catcher comes up, and that's pretty much it. Again, I could play with the speeds here. I don't know. I can go 400 on 12L. And this here is the regular cutoff cycle right here. A lot of times in my programs I'll have something like this, which is the same thing except for it doesn't do any work. It just comes over and cuts straight off, and that's just for cutting off like a new bar. So that's where you'll see it says new bar. Anyways, with this, there's really nothing to change at all except for the surface speed. Change that and everything else will work fine. Alright, so right there, I wrote a whole program for this part besides the hole, and we did it by changing, let's count them, 1, 2 numbers. Real numbers I had to change, 3, 4, 5, 6, 7, 8, 9, 10. Nothing there. 11, 12, 13, 14, 15, 16, 17, 18. 18 digits is all I changed in that whole program to make it functional, and now it is a legit program that will run and it'll produce that part. So when you get good at programming and understand what needs to be filled in where, you repeat a lot of things. That's where these variables are very helpful because it just eliminates having to keystroke. Beyond that, it's very helpful because a lot of times when you are keystroking, it'd be very easy for me to write, instead of writing pound 102 here, if it said it's supposed to be 1 inch 300 thou, well, I might accidentally write 1.03. Well, then it's a potential crash. So if I have this tuned in and I don't have to change this, there's less keystrokes that I'm going to make errors on. And the fact that it automatically sets the offset right here, and then there's no way I can actually run into the chuck is unless I change a hard Z value to a distance longer than my part length, everything will work. The farthest point I turn is right here, and that's 103, which is established by pound 100 and 123. So even if I messed up and I put in, a 5-inch part length, all it's going to do is stick it out 5 inches and then turn back 5 inches plus 123. So it's not going to run in the chuck really. I'm not going to say no matter what, but the chances are a lot slimmer. So there's a fast little program. You can see how much value the variables add into here just to make life easy and produce a program in seconds. This is why I do not like Mastercam Lathe, because I can go through here, and I talked a lot through this, and we're at 13 minutes in this video. And I mean, I think I could have wrote it in probably 5 minutes flat if I wasn't talking and explaining any of it. So that's how fast I can create a part versus having to go to a software and get it drawn up or import it and then create the tool path and all that work. So when you know these CAN cycles and know how they function, you can fill in these variables a lot easier. So, all right, so if you've taken a programming class, it probably meant something to you. If you haven't taken a programming class before, aren't you signing up? So otherwise, that's kind of it there. I will probably go out and run this in the machine just so you can get a visual on how it all works and how fast and easy this really was. So, thank you.